Hi everyone, welcome back to Ramna Sir Physics. How are you all? Today topic is Doppler effect. Intermediate second year CBSE, the Doppler effect in sound. So very important case. So maximum students confuse in this Doppler effect case. Here what is Doppler effect? Here we are observing. So with good example we'll discuss Doppler effect in sound. Here a whistling train, so we have to take as a source and one observer, and this whistling train so as a source of sound, so we are taking that one. So whenever whistling train is moving towards the stationary observer, so what happens, so the stationary observer can receive more addition of the waves. When both are at rest, source and observer both are at rest, he can receive n number of frequency of waves. Here, for example, observer is at rest, source is in motion. So that time what happen? The person can receive some additional waves. The same case, if source is at rest, whistling train is at rest, observer is moving towards the stationary source, so then also the person can receive additional waves. Here, for example, the observer is at rest only, the whistling train is moving away. So what happens that time? The person can receive less number of waves. Why? Because the source of sound is moving away. Here, for example, source is at rest, the observer is moving away. So what happened? He receives some less number of waves. Here, the change in frequency, okay, whenever relative motion, either source or observer, so both in relative motion, so that time the change in frequency only called what? Apparent frequency. The frequency is called what? Apparent frequency. Here the Doppler effect means the apparent change in the frequency heard by the observer due to relative motion between the source and observer is called Doppler effect. What is Doppler effect? The apparent change in the frequency heard by the observer due to relative motion between the source or observer. Okay, relative motion between source and observer is called Doppler effect. How many cases? 3 cases are there in this. First case is what? Source is in motion, observer at rest. And in this case only observer at rest only, source is moving away. So what will be the apparent frequency formula? We have to derive. And at the same time, okay, so observer is in motion, source is at rest. Observer is moving towards the stationary source. Observer is moving towards the stationary source, and observer is moving away from the stationary source. What will be the apparent frequency? So that also we have to derive. So next, both are in motion, source also and observer also both are in motion, moving towards, then both are moving away. So what will be the apparent frequencies? So these all we have to derive. In this first case, the source is in motion and observer is at rest. Here you can observe, here S denotes source. Okay, source means what? Whistling train. And O denotes observer. Observer means the person. In this first case, observer is at rest, source is in motion. So with what velocity? Vs. The source velocity is what? Vs. With Vs, okay, velocity of the source is how much? Vs. With velocity Vs, okay, the source means whistling train, is moving towards the stationary observer. When both are at rest, source and observer both are at rest, so the person can receive n number of frequency of waves. So that time the distance between the source and observer in 1 second, so the distance is how much? The wavelength lambda I am taking. Okay, now the person is at rest only, the observer is at rest only. Now source is started with velocity Vs. Okay, so after reaching at S1 point, for example in time t, the person reached at S1, displacement equal to what? Velocity into time. With what velocity is moving? With Vs velocity is moving, Vs into t, velocity into time I am taking. Okay, so till s1 distance, okay, the traveled by the source is how much? Vs into t. Now wavelength is decreased. The decreased wavelength is how much? Say lambda dash. The decreased wavelength is how much? Lambda dash. Now the apparent wavelength, okay, this change in wavelength, apparent wavelength lambda dash equal to the apparent wavelength lambda dash equal to apparent wavelength lambda dash equal to, okay, so what we can take this vst, okay, minus, okay, total is how much? Apparent wavelength lambda dash, okay, lambda dash means what? S1o, okay, so S1o equal to what we can take? SO minus SS1, minus SS1 we can take lambda dash equal to what? SO means what? Total wavelength lambda minus SS1 velocity of source into time t. Okay, so we know that reciprocal of the time period is what? Frequency. So that is why what I am taking lambda dash equal to, okay, lambda minus this Vs by n I am taking. So why? Because reciprocal of the time period is how much? Frequency, or the frequency and time periods are both are reciprocals. Okay, n equal to 1 by t. Now what I am doing? So lambda dash equal to, here we know that formula v equal to n lambda formula. Lambda equal to what? V by n minus this Vs by n is as it is. Since I am writing v equal to n lambda formula, lambda equal to what? V by n. Take n, we can take LCM. Now v minus Vs. This is just apparent wavelength only. We have to derive the apparent frequency. Okay, so from apparent frequency formula, okay, from v equal to n lambda, from v equal to n lambda formula, so apparent frequency n dash equal to v by lambda dash I am writing. Apparent frequency, okay, n equal to what? V by lambda. N dash equal to what? V by lambda dash. N dash equal to V by lambda dash value, how much we got? V minus Vs by n. This n sent to numerator. So what happened? Therefore, apparent frequency n dash equal to V by V minus Vs into n. V by V minus Vs into n. So this is the derivation for when the source is in motion and observer at rest. In that, source is moving towards the stationary observer. Source is moving towards the stationary observer purpose. This case. Check once. Here S be the source and observer, O be the observer. Observer is at rest only. So whenever source and observer, the distance is in 1 second traveled frequencies of waves and I am taking the wavelength is lambda. Whenever source is started with velocity Vs, after traveling at S1 distance, how much? Velocity into time, distance equal to what? Here, okay, displacement equal to, we are taking velocity into time. The new wavelength, that is lambda dash, that is apparent wavelength. Apparent wavelength equal to what we taken? S1o. This value we need. Total wavelength SO minus SS1. Okay, here SO is how much? S2o, that is lambda, minus SS1 is how much? Vs into t. Lambda minus Vs, the t is what? 1 by n. Here v equal to n lambda, from that lambda equal to what? V by n. N is the LCM, v minus Vs by n. Now the frequency and wavelength relation is what? From v equal to n lambda formula, the apparent frequency n dash equal to what? V by lambda dash. N dash equal to v by lambda dash is how much? V minus Vs by n. Here sending numerator, okay, what happened? V by V minus Vs into n. This is for when source is in motion, observer is at rest, that is source is moving towards the stationary observer. Now in this special case, if source is moving away, okay, this observer is at rest only, source is moving away from the observer, stationary observer. What happened? So whenever source is, this whistling train is moving away from the observer, so what happened? The frequency of waves heard by the observer decreases. Okay, so your frequency of waves decreases, less number of frequency of waves you can listen. Here that the in the final apparent frequency, what we can take, n dash equal to v by v plus vs into n. So this is the first case when source is in motion, observer is at rest. Second case also there, so that also we'll discuss. Second case is what? Now observer is in motion, source is at rest. Okay, we'll take. Here second case, the observer is in motion. Okay, observer is in motion and source is at rest. Here before discussing second case, one definition, Doppler shift means what? What is Doppler shift? Listen here, when source is moving towards the observer or observer is moving towards the source, so we'll say they are in relative motion. Here for example, source is moving towards the stationary observer, so the apparent frequency is what? Greater than the actual frequency. Otherwise, source is moving away from the stationary observer, so that apparent frequency is less than the actual frequency. This shift in the frequency, the change in apparent frequency and actual frequency is called Doppler shift. Is called Doppler shift. Now second case we'll observe. When observer is moving towards the stationary source, when both are at rest, the person can receive n number of frequency of waves. So the wavelength is what? Lambda. Here now the observer is moving towards the stationary source. Okay, stationary source. The source is at rest, whistling train is at rest. Now the person observer is moving towards. Observer is moving towards with what velocity? V0. So V0 is the observer velocity. Here whenever observer is moving towards the source, observer is moving towards the stationary source, the person can receive more additional waves. Okay, so how many additional waves means depends on the speed of the observer, that is V0. Here how many additional waves means, listen here, the apparent frequency increases. Why? Because observer is moving towards the stationary source, source is at rest. That time n number of frequency of waves, okay, additional number of frequency of waves the observer can receive. So that is why the apparent frequency n dash equal to original frequency, actual frequency is what? N, plus some additional waves also he can receive. Why? Because the observer is moving towards the stationary source. And how many additional waves means depends on the speed of the observer. Here that is why V equal to n lambda, we know that n equal to what? How many additional waves means n equal to V by lambda. Here V means observer velocity V0. Since why we taken V0 by lambda? Observe here from V equal to n lambda formula. Okay, so here the additional frequency n equal to what we taken? V by lambda. So that is why V0 by lambda we taken. Here we know that lambda. Okay, so lambda means we know that V equal to n lambda. Lambda equal to we can write V by n, we can write lambda equal to V by n, we can write. Okay, substitute here n dash equal to n plus V0 by lambda means what? V by n. This n I am sending to numerator. N dash equal to n plus V0 by V into n. So this n is in denominator, again in denominator. We can shift to numerator. Okay, V0 by V into n. N I am taking common. N dash equal to n I am taking common. What? 1 plus V0 by V into n. Here V is the LCM, so therefore what happens? Therefore apparent frequency n dash equal to V is the LCM, V plus V naught by V into actual frequency n. So this is the formula for when observer is in motion, source is at rest, and that observer is moving towards the stationary source, moving towards time. What is the formula? N dash equal to V plus V naught by V into n. Here V is what? The speed of sound. V value is how much? V is how much? Speed of sound. V naught is the observer speed. Okay, V naught, V plus V naught by V into n. So in this special case, for example, observer is moving away. Observer is moving away. Here person is there. The person is moving away from the stationary source, whistling train. Okay, the source what we are taking, whistling train we are taking. The person is moving away. So that time what happened? The person can receive less number of waves. Whenever moving away, the person can receive less number of waves. So that time what happened? Here apparent frequency what happens? Decreases. Actual frequency compared to actual frequency, the whenever moving away time, so the apparent frequency decreases. So that is why here what will take? Minus will take. In every equation take just simply minus you take. So that time what will get? V minus V naught by V into n. So this is the second case. So along with Doppler shift definition, they lost. When observer is in motion, source is at rest. So derive the apparent frequency formula. First you have to derive observer is moving towards. Next you have to derive observer is moving away. In this third case also there, but the third case is for numericals purpose most important. Observe here, third case is what? Now both are approaching, both are in motion, source and observer both are in motion. So first case both are approaching and second case both are moving away. Here source and observer both are moving towards, source and observer both are moving towards each other. So that time what happened? The apparent frequency increases. Here source and observer both are moving towards. The source is moving with velocity Vs and observer is moving with velocity V naught. For example, when source is moving towards, what is the formula? Apparent frequency formula is what? N dash equal to V by V minus Vs into n. Observer also in motion. What is the formula? V plus V naught by V minus Vs into n. So after combining, you will get the formula N dash equal to V plus V naught by Y, because observer is in motion and source is in motion, that is moving towards. What is the formula? V minus Vs into n. Okay, when both are moving towards, so that time formula is what? V plus V naught by V minus Vs into n. For example, in this, okay, source and observer, so both are moving away. So source is moving with speed Vs, observer is moving with speed V naught. So both are moving away. So that time apparent frequency formula is what? Just to change the signs, V minus V naught by V plus Vs into n. V minus V naught by V plus Vs into n. And this Doppler effect phenomenon applicable when the source's velocity and observer velocity much less than the speed of velocity. So then this Doppler effect phenomenon can applicable. Okay, let's see numericals how they lost. Okay, attachment numericals also they lost. You can check the question on screen. A train sounds its whistle as it approaches and crosses a level crossing. An observer at the crossing measures a frequency of 219 Hz as the train approaches, and the frequency of 184 Hz it leaves. If the speed of sound is taken to be 340 meters per second, find the speed of the train and frequency of its whistle. You can observe here the given. So when the train is, okay, whistling train is approaching the observer, so that time how much they got frequency, apparent frequency 219 hertz given. First I am writing. So next, moving away time, n double dash I am taking apparent frequency. The frequency what happened? Reduces. So that is 184 hertz. And here speed of sound is given 340 meter per second. Then they are asking speed of the train. Okay. Source speed is how much, and actual frequency n value how much they are asking. Apparent frequencies for both the cases the only given. Substitute here. When source is moving towards the stationary observer, what is the case? N dash equal to V by V minus Vs into N. Here N dash value is given. How much given? 219 is given. V by V minus Vs into N. This is say equation 1. Next, here source is moving away. Okay, so it is cross the observer. Observer is at rest only. Cross the observer and moving away after crossing. So moving away. So here observer is here only. Observer is here only. Observer at rest. Okay, the source is moving away. Source is moving away. So that time with velocity same speed only. Okay, Vs. So what happened that time? Source is moving away from stationary observer. What is the apparent frequency formula here? N double dash I am taking. V by V plus Vs into N. Okay, here N double dash value is given. How much given? 184 hertz they given. 184 is equal to V by V plus Vs into N. This is a equation 2. This is a equation 2. Now equation 1 divided by 2. Take this one. Equation 1 divided by equation 2. Okay, so here 219 by left hand side I am dividing first is equal to right hand side I am dividing V by V minus Vs into N by V by V plus Vs into N. NN gets cancelled and VV gets cancelled. So then what happens? V plus Vs by V minus Vs. Substitute the values. V plus Vs. V value is how much? V value is given 340 plus Vs we don't know by 340 minus Vs. Cross multiplication. 219 into 340 minus Vs is equal to 184 into 340 plus Vs. Okay, solve this one, just to multiply and then you solve this one, you'll get Vs value, you'll get 29.5 meter per second. You'll get the source velocity, how much we got? 29.5 meter per second you'll get. Then this Vs value substitute in any one equation. Okay, so first equation I am substituting. Equation 1 implies how much? 219 is equal to V value how much? 340 by 340 minus Vs value how much we got? 29.5 into N. Okay, so therefore N equal to what happens? 219 into cross multiplication 340 minus 29.5. So I am taking 310.5 by 340. Okay, by 340. Therefore solve this one, you'll get N value, you'll get 200 hertz. You'll get N value, you'll get 200 hertz. So this is the derivation. Okay, this is the derivation for this case. The source velocity 29.5 meter per second and the actual frequency N value 200 hertz. So next problem we'll see. Two trucks heading in opposite directions with speed of 60 km per hour and 70 km per hour respectively approach each other. The driver of the first truck sounds his horn of frequency 400 Hz. What frequency does the driver of the second truck hear? Within the bracket they given velocity of sound 330 meter per second. And second case also they are asking, after the two trucks have passed each other, what frequency does the driver of the second truck hear? You can observe here which case this one, both are in relative motion, source and observer. Here source and observer, the persons are what, two trucks only here. So one person, okay, one truck person giving horn, another truck person is okay listening that horn. So here both are okay, source and observers are two trucks only, and both are in relative motion. Both are in, first of all they are approaching, then they are moving away. Here the source and observer, the speeds are given in kilometer per hour. They given, we have to convert to SI units. 60 kilometer the source speed is given. Okay, the truck person who is giving horn, so the person speed is given 60 kilometer per hour. We have to convert this one, 60 into kilometer per hour to meter per second is what, 5, okay, into 5 by 18. So this is in meter per second. Okay, so meter per second, just multiply here, 65 ja 300 by 18 meter per second. Next, like that only, 70 into 5 by 18 kilometer per hour to meter per second, 5 by 18. Okay, so how much, 350 by 18 meter per second. Okay, 350 by 18 meter per second. The first case, okay, case 1, what is the case 1? First case, when source and observer both are approaching, source and observer, okay, so with speeds vs and v naught they are approaching. So we know that formula, n dash formula, how much, v plus v naught by v minus vs into n is the formula. Substituting this, so what will get here, okay, substitute n dash equal to v is how much given, 330 given, plus v naught, just now we got 350 by 18, 350 by 18 we got, okay, 350 by 18 we got, divided by v 330 minus 350 by how much we got, 18 we got, okay, into frequency is given 400 hertz. Okay, actual frequency is given 400 hertz. Okay, solve this one. So what happens here, okay, so solve this one, n dash equal to 18 into 330 into 18 plus 350 by 330 into 18 minus 350 into 400. So here 18 into 333, okay, so we'll get approximately, we'll get 594 will get, okay, 594 will get, into 0 is there, 5000, okay, so 940 will get, plus 350. So that time you'll get the, how much you'll get, plus 350 means 6290 you'll get, 6290 divided by, so here how much you'll get, so 5640 will get. So after solving this total, so you'll get the answer, how much you'll get, 446 hertz you will get. Solve this one and check, 446 hertz you will get, the frequency you will get 446 hertz. Okay, 446 hertz. Next, the second case, case 2 is there. What is the case 2? Both are moving away. So your source and observer both are moving away. This is the source, the observer both are moving away with v naught speed and vs speed. So that time apparent frequency formula is what, n double dash I am taking, n double dash equal to v minus v naught by v plus vs into n. Substitute the values here also, n double dash equal to v 330 minus v naught, how much, 350 by 18 divided by 330 plus 350 by 18 into 400. Therefore n double dash value you will get, how much you will get, n double dash value 358.33 hertz. So this is the second case. You can observe here the apparent frequency whenever both are moving away decreasing. Here both are approaching, apparent frequency value increases. Okay, so this is a Doppler effect second case. Okay, second case attachment problem or first case attachment problem they can ask. Okay, so I hope all are understood this Doppler effect phenomenon. Okay, so if you are watching this channel first time, please subscribe the channel and you'll get more competitive topics also. You'll get JE and NEET topics also you'll get. Thank you so much. This is Ramana sir, Physics.